Okay, I think we have waited enough, so I think we should start now. Okay. Good evening, everyone. I welcome you all to the live session number 3 for hydrogen energy, production, storage, transportation, and safety. So the course instructor is Professor Pratibha Sharma from IIT Bombay, and I'm this course T. Amit Kumar Sharma. So as you all know that every week, mostly on Friday from 6 to 8 p.m., we have a live session. So the purpose of this session is to discuss the previous week's assignment question and to discuss about some uh, basic theories also that has already been covered by the professor. So the PPT and this recording of this meeting. So this meeting is being recorded. So the recording will be provided to you from the NPTEL team. So those who are not able to attend today, they can access it later. Okay, so let's start with today's session. So we have already covered the outline. So in this we will cover the hydrogen production, storage, safety, transportation, and all. So okay, yeah. So let's start with the questions. So what is the temperature range of the catalytic methane decomposition process if nickel is used as catalyst?
1100 to 1300.
Okay, so
500 to 650.
we have two answers. One is 1100, 1300. Second is 500 to 650.
500 to 650.
Okay. Anyone else? Uh, your voice is not clear.
500 to 650.
Okay. So do you want to explain why this lower temperature?
Because catalyst is used. That's why
Yes.
low temperature.
So what will do the so what is the working of like catalysts? Why the temperature is reducing?
Because the rate of reaction will be increased even at a lower temperature with the help of catalyst.
And the require energy to break the bonds
The bonds.
will
Yeah.
decrease. Yeah.
Yes.
Okay. So let's see the answer. So the answer is C. The answer is 500 to 650. So as you can see here, it is the catalytic methane decomposition. So as name suggests, we will use a catalyst to do the decomposition. Okay. So there are two types of decomposition, catalytic and non-catalytic. So in catalytic one, we will use a catalyst to do the decomposition of methane. So that will help to reduce the temperature, also reduce the energy required to break the bonds. So the temperature for the catalytic methane decomposition is 500 to 650 range. For non-catalytic, it will be around 1100 to 1300 degree centigrade. So this is the basic reaction of methane decomposition. So you can see here, this is the methane CH4. So it will decompose into solid carbon and 2 hydrogen. So by decomposing methane, you can get hydrogen and carbon as a solid phase. So the beauty of this method is that you can, because the carbon is in solid phase, so you can easily separate it out and you can use it for some other purpose. And you are only getting the hydrogen. So there is no other gases. So you are getting a solid carbon that you can use for other process and you are having pure hydrogen. So that's why it's very popular. Energy required, so it's 75.6 kilojoule per mole. So there are some other things about this methane decomposition process. So non-oxidative decomposition of hydrocarbons. So we are not using any oxidation and all. solid carbon is formed. So you can see here, easy to sequester, no emission. So you can easily separate this carbon and there is no emission. Fewer processing steps, no water gas shift reactor or CO2 removal. So because if you compare the steam methane reforming, dry reforming, autothermal reforming, and we have covered various reforming techniques and also various methods to produce the hydrogen. So in those methods, you know that because there is hydrogen and also there is CO. So to further convert the remaining CO into hydrogen, we need water gas shift reactor. And when we use water gas shift reactor, then there will be CO2 also. Okay. So we need to have a water gas shift reactor, then we need to have a CO2 removal step. So mostly we can use PSA, and there are also various chemical methods are also there, membrane you can use. So basically there will be more steps, the complexity will be more as compared to this process. The separation is easier, it will have a good efficiency. The color of this hydrogen. So as we know that we are having a color coding for the hydrogen based on the process and the feedstock. So for this, it will be a turquoise hydrogen. And the methane being inert requires for non-catalytic decomposition, it requires 1100 to 1300 degrees centigrade. For non-catalytic, solar or plasma or electric arc furnace or molten metal you can use. Molten metal bath or pulsed microwave power. So you can use because you need very high temperature. So these are the methods to get this high temperature. In catalytic process, solid carbon product deposition. So because if you are using catalytic method, so because you are using a catalyst and there is a direct, you can see solid carbon is there. So there is possibility that this carbon will also deposit on your catalyst. So in long term, that will hamper the efficiency of the catalyst. Okay, so it can deactivate the catalyst. So this is a drawback of this catalytic methane decomposition. So what is the mechanism of this CDM? So there are two mechanisms proposed. The one is free radical mechanism and the second one is stepwise dehydrogenation. So the first step will be chemisorption of methane, then dissociation, like you can see the radicals will come out. Okay, then further stepwise dissociation, then the formation of hydrogen molecules, then the carbon nucleation growth. So and different compounds can be there. Similarly like this. So for more details, you can refer these references to learn more about these mechanisms, and you can also use Science Direct to learn more about the mechanism of this catalytic methane decomposition. So when we are using the catalytic methane decomposition, so the catalyst size, the morphology, the pore structure, the electronic state, dispersion, surface area, the preparation method that is used for the catalyst, the defect structure. So they all impact on the conversion, stability, and products produced. So the conversion that is happening, okay, the the hydrogen that is producing and the stability of the whole reaction. So those depend on the catalyst. So these are the factors very important, and the type of carbon produced depend on the catalyst. So there can be different types of carbon. Okay, so that will also depend on the catalyst. The carbon deposition is a major problem. So this is a major problem because if carbon deposition is there, then suppose this is your catalyst. So there is carbon deposition. So it will cover the catalyst and basically reduce the active area that is required for the reactions to occur. So after some time, there will be no reaction because the catalyst is totally covered with the carbon. And these are the temperature ranges for the catalyst. So you can say nickel is 500 to 650, Fe 700,000. So these are the ranges. So if you go for higher temperature, then you can go for non-catalytic decomposition. Then you can use molten metals. Next question. Which type of carbon structure has highly catalytic activity? Has high catalytic activity? So disordered carbon structure, intermediate carbon structure, ordered carbon structure, or graphite.
Disorder carbon structure.
Disorder.
Okay. And what is the explanation?
Because the structure is
Surface area.
not uniform,
Surface area. Hmm.
so it can easily
Surface
react.
area would be more. Yeah, surface area would be more
Yeah.
in case of disordered carbon structure.
Yeah, good point. So surface area is more. And what is the purpose of surface area in the catalytic activity?
It increases the reactivity. I mean,
Yeah.
more
So if the
surface area, more react. Yeah.
yeah, so the more surface area means there can be more reactions. Okay, more reaction sites are there. Okay, so it can increase the catalytic activity. So the correct answer is A, disordered carbon structure. So in the catalytic deposition, like in methane deposition, sorry, in this technique CDM, so it's so we are also use some support to support the catalyst. Okay, so support. What is the use of support? So they promote dispersion, prevent agglomeration, and promote reducibility of catalyst. So these are the support: aluminum oxide, magnesium oxide, titanium oxide, silicon oxide, zirconia oxide, and zeolite. So these are the support we use. So the choice of catalyst, promoter, and support, they are selected to delay the deactivation, because we know that if we are using a catalyst, then there will be carbon deposition, okay, and it will be get deactivated. So we need to select the catalyst, promoter, and support so that we can delay the deactivation. So there are two methods like encapsulation or diffusion. Okay, so in encapsulation, the carbon formation will directly cover the whole catalyst. So you can see the nickel is a catalyst, so the carbon has completely covered the nickel. Okay, so active sites totally blocked. Okay, so there will be no reaction because the catalyst is totally covered with the carbon. In the diffusion, you can see there is a support. Okay, so there is a catalyst, so the carbon will start uh, over this catalyst, and after some time it will try to lift the catalyst, but still there will be some area. Okay, so basically it can delay the deactivation, but it is not covering the whole catalyst. Okay, it is covering part of the catalyst, part of the active sites of the catalyst, but the remaining part is there. Okay, so some part is covered. You can see the carbon fiber will start forming like this, but you can see there are some sites available. Okay, so still there can be catalytic activity can be there, so maybe your conversion will reduce, but you will have the conversion. So after some time it will lift the catalyst and can get into the carbon product, so it is better for catalytic activity.
Sir,
So
one
there
doubt.
are, yeah,
So in the earlier slide, actually, we have seen two methods of deposition, right?
yeah,
Encapsulation and diffusion.
yeah.
So both will happen, or any one will happen, and what are the factors? Like, how do we when can we say encapsulation is more or diffusion is less, or some vice
So
versa?
it depend on, as we have discussed, like promoter and support. So if you are having the also proper support,
Okay,
then only eh, so it depend on that actually. So if you are
okay.
having
So if
support, yeah,
yeah, if no support, then maybe can we say fully
yeah.
encapsulation will
So
happen?
yeah, if you are not using supports, then there can be encapsulation. If you are using supports, so that support will prevent the encapsulation and the diffusion kind of things will be there.
Okay, okay, right.
Yeah.
Thank you.
And it also depend on the catalyst. Okay, so here we are taking the example of nickel. So it also depend on the catalyst, support, and promoter. So for different catalyst, maybe the diffusion encapsulation can be different. So you need to understand depend on the catalyst you have to check. Okay.
So
So
if
which catalyst you are using?
yeah, if suppose noble metals if we use as a catalyst, then still there won't be any encapsulation, right? In that case, or how it is?
So actually you need to look into it. So I'm not aware of that. So because it depend on the support also.
Okay, 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 sir,
Yeah.
right.
So
Thank you.
for more detail, I think you should refer a reference book.
Okay, sure. Thank you.
Yeah. Okay. So we can also use carbon-based catalyst. Okay. So the metal catalyst show higher activity and has lower operational temperature, but deactivation due to encapsulation. So we have seen if we are using the nickel, so we are having higher activity, temperature is also lower, but the deactivation can be there. But if you use suppose carbon as a catalyst, okay, so it can have lower activity and higher operational cost. But there is also an advantage. Advantage is that the cost will be low, better stability against deactivation because the carbon is itself as a catalyst. So when the carbon deposition will be there, then the deposition also acting as a catalyst. Okay, so the stability against deactivation will be there. Sulfur poisoning is not there. Carbon product not poised with the toxic metals. Thermal stability till high temperature. So it's also advantage. Burning of for regeneration not required. And carbon form may also have the catalytic activity. It's also for fuel flexibility. And carbon encapsulate will also carry catalytic activity. So these are the advantage of the carbon based catalyst. But disadvantage is that you require high temperature and the activity will be lower. So you need to also look into the conversion. So the disordered one, the carbon black, activated carbon, amorphous carbon, char, they are come under disordered. Intermediate order like pyrolytic carbon, glassy carbon, fluorine soot, fluorine CNT, carbon nanotubes, CMK, etc. Highly ordered are diamond and graphite. So then we have covered one question initially. Which type of carbon structure has highly catalytic activity? So the disordered carbon structure. So the disordered one comes under this. The carbon black, activated carbon, amorphous carbon and char. So these are disordered. So they will have more surface area. They can have more catalytic activity. So activated carbon have better catalytic activity and carbon black have better stability. So the methane decomposition require specific surface area, defect concentration, dislocation vacancies, lower coordination sites, pore volume, size, and pore size distribution. So these are the factor which are which also have like high impact on the catalytic activity. So you can see surface area is here. Also the pore size, pore volume. Activated carbon have better activity and carbon black better stability. We have covered this. So the activated carbon can be from coconut, palm, olive, and almond. So blocking of the pore mouth is the major problem in case of activated carbon, although it gives higher conversion. So there is an issue is the pore mouth blocking in activated carbon, but it can give you high conversion. Carbon black is less of pore blocking issue, and deactivation slows down at higher temperature, better diffusion of reactant. So if you are using high temperature, then we are having carbon based catalyst, so the diffusion will be good. So the type of carbon product. So it depends on the reaction condition and catalyst used. Non-catalytic process result in amorphous carbon or carbon black. CNT and CNF with metal catalyst. Nickel forms CF, ferrous forms CNT like this. With carbon catalyst, active carbon produced carbon black or CNF or layered carbon. Okay. So these are the product which formed in this. So the regeneration of the catalyst. So we can also do the regeneration. So You can see the carbon that is deposited can react with the steam, oxygen, okay, and CO2. So H2O, O2 and CO2 can be used for the regeneration. So life of catalyst less than 10 hours, and most commonly used is steam gasification oxidation. Excessive heat in oxidation can lead to complete powder formation. Regeneration with steam is preferred. Formation of hydrogen, and don't change morphology of the catalyst. That's an important point. Which oxidant is preferred? So the regeneration with steam is preferred because it for the formation of hydrogen, and don't change the morphology of catalyst. So you can see here CO and H2. So in summary, so the deactivation is catalyzed by poisoning, sintering, coking. So purity of carbon powder is lower, incomplete conversion, problems in collecting carbon product, activity of catalysis is short-lived, and deactivation is there. So if support has oxygen, it can result in CO2 formation. So because we have seen the support can be aluminum oxide, zinc oxide. So if there is oxygen, so it can also result CO2 formation. So deactivation of metal catalyst by carbide formation, molten salt or metals, corrosion and high operating temperature. So need of high performing and efficient catalyst. Economics depend on product carbon value and how much methane conversion. So if we consider the economics, so if you are, suppose you are getting the solid carbon, so if you are selling that carbon, if you are using that carbon in for a different method, there you can do some value addition. So then it can be economic viable, otherwise it's difficult. Also the methane conversion, demand of carbon product is not sufficient. So because you are having a carbon as a product and there is no sufficient demand, that's why economical, so economics of this method is challenging. So which among the following is mixed in petrol? 50% ethanol, 5% methanol, 10% biodiesel, and 5% ethanol.
5% ethanol.
5% ethanol.
Okay. Anybody else?
5% bioethanol.
No, there is no option of bioethanol. So option is ethanol, methanol, biodiesel, and 5% ethanol. So we have answer is like 5% ethanol. Any explanation?
Yeah, cost of production of ethanol is less as compared to this petrol, because we are importing petroleum, and ethanol can be produced here from sugar cane. Even we used to produce ethanol, and I just ethanol at our plant. So even government is now increasing 10% instead of 5%. So main is the cost, and second is ethanol is easily mixable and can have a calorific value which can be mixed with the petrol.
Yeah, nice. Very good answer. So yeah, ethanol we can mix it. Okay, because ethanol is also having calorific value. So we can mix it, and also if we mix it, so there is no major modification required in the engine also. So you can have similar the power output from your engine. And if you are using 5%, so you are reducing the 5% petrol. So then you only got 95% petrol. So basically, if one vehicle is using suppose 1 liter, so see the number of population of and the number of vehicles. So it is a huge number. So you can save a lot of petrol, fossil fuel. Also the ethanol generation. So you can generate ethanol from various methods. So like one of you have already said, from the sugar cane, from sugar factories you can generate the ethanol. Okay, so you can also from the waste also you can generate the ethanol. Okay, so basically you are also reducing the waste, you are reducing the greenhouse emission and you are using it as a fuel in your vehicle. So that will also, so it's like a win-win situation. Okay, you are reducing the fossil fuel import, you are reducing the fossil fuel use, you are using your waste material to generate the fuel. So due to that, we are mixing the ethanol in the petrol. And as you said, the government is planning to increase it. Okay, and I think various testings are also, like maybe in near future, this percentage will be increased. So the quality of ethanol maybe is also depend, and maybe in near future it will increase. So let's discuss about the, so as we are discussing about the ethanol, so let's discuss about the biomass potential, because we can generate like bioethanol, okay, from biomass. So the biomass potential, so the feedstock for biomass power production. So if we want to produce power from biomass, so what are the feedstocks? So first is energy crops, agro-industrial waste, agriculture waste, municipal solid waste, and forest waste. So energy crops can include plant exclusively grown for their wood from marginal lands for energy generation. Example, bamboo, etc. So in Brazil, Venezuela, I think in some other countries also, they are in US also. So uh, they are producing crops only to generate the energy. So basically they are generating the ethanol or maybe different kind of, maybe the biogas or different kind of energy. So the energy crops means the crop they are growing, they will not use for the like they will not use it as a food. Okay, so they will only use that crop to generate the energy. So that's why it's called energy crops. Then the agro-industrial waste, so the waste from paper mills, sugars, and the refineries. Okay, just 1 minute. ले जाइए आप इसको. हाँ हाँ मेरे पास. Sorry. So the agro-industrial waste, so the waste from paper mills, the moisture from the sugar mills, okay, refineries. So we can use these waste to generate ethanol, biogas, because now from the sugar mills, the press mud is widely used for the biogas production, and they are upgrading the biogas into the CBG. And government of India under Satat scheme, so they are investing around, I think, 2 lakh crores, and currently 68 to 69 plants are already operational, the CBG plants. So they are using some kind of organic waste to generate the biogas, and they are upgrading that biogas into the compressed biogas CBG, that is equivalent to methane, but because the CBG is having more than 90% of methane. So you can consider it like the CNG, okay, or bio CNG. But in India, we call it CBG, compressed biogas. So you can directly fill the CBG in your vehicle instead of CNG. So basically, we can reduce our natural gas import, and that can save a lot. Also, it is considered as a renewable energy. So that's also a good point. So the sugar, the press mud from the sugar mills is widely used in the biogas generation. And also you have seen the parali issue in Punjab and Haryana side. So there are also so many biogas plant are have already installed or being installed. So to use that parali to generate biogas and further to convert into CBG. Agriculture waste, we can use agriculture waste also. We can do, we will see the further methods like, but the biogas is widely used now. We can also do the gasification, pyrolysis, combustion, the municipal solid waste, and the forest waste. So these are the feedstock for biomass power production. And there are different routes to produce the power. So we will go through those. So there is a carbon neutral. So it's like you can see. So we are generating the vehicles. They are doing the pollution. So it's going into the atmosphere. From the atmosphere, the plants are taking the CO2. So it's kind of a cycle you can see. So if the pollution is not that much, then the cycle is like earlier it was quite in a balance, but now we are decreasing the forestation, we are decreasing the plants, but we are increasing the vehicles population, energy consumption. So this is increasing very fast at a rapid rate, and the CO2 that is used, it's very low. Basically then there is an imbalance. Okay, so that is the reason for the global warming, climate change. So it's very important to understand this. So now we want to use, instead of fossil fuel, we are trying to use biogas, bioethanol, renewable fuel like green hydrogen like this, so that we can remove or we can decrease the CO2 amount, so that we can again come in a balance. Okay. Next question. Which of the following method gives direct energy from biomass? Biological, combustion, pyrolysis, and gasification. So the direct energy from
Sir,
biomass.
combustion.
Okay.
Biological.
We have answer combustion. We have another answer biological. Anyone
Biological.
else?
It's pyrolysis.
Pyrolysis. Okay. So it's good because we have different answers. So I think it's good to discuss. So let's start with the option A, biological. So those who are in favor of biological, please explain what is your reasoning behind this answer.
Because other three need energy, like a power supply, like that. Combustion, it will produce carbon.
Okay.
Like that, biological, it will be happen by microorganism.
Okay. And who are with the combustion, please explain your reasoning.
Yeah, the reason is the combustion. Why is a biomass on its own cannot get if it has to, if you have to generate energy, heat has to be done. This has to be ignited. It has to be pressurized. Only then you get the real value out of it. For example, biomass gasifiers, which are there, which use the forest residue or any agricultural residue, which is used for power generation. It's all based on combustion, which runs with the existing IC engines.
Okay. So you are with the combustion, right?
Yeah.
Okay. Option C, pyrolysis.
See, in pyrolysis, basically, when we give heat to the biological substance, then it will give the energy. So the difference between combustion and pyrolysis is just we are heating in the air, but in combustion at a stoichiometric ratio, enough oxygen is to be given. So then only energy will be produced. So that's why we
Okay.
have gone with the pyrolysis option.
Okay. And D, gasification. Okay, so nobody with the D. So let me come again to the question. The question is, okay, so you all know about these methods. So those who have explained, so they have explained good. Those who have explained about pyrolysis, so that's good. Okay, but what is the question? The question is, which of the following method gives direct energy from biomass? I think one of you have raised the hand. Yeah, please.
I think we interpreted I interpreted the question wrongly.
Yeah.
Direct energy from biomass means direct energy is the one, sorry, I did not get case name. It is just like what we used to have the biogas, which by microbes it is just generating. wherein you are not adding any energy, it is just coming out of on its own by digestion. This is
Yeah.
the right one.
Yeah. So go through the question again, because it's very important that you are going through the question, okay? Because you all know about these methods, but the question is which method is giving the direct energy. So let's say direct means directly you are having the energy, okay? You don't have to do so much things, you don't have to invest so much thing like so many rupees or so much like manpower, anything. You don't have to invest, you can get direct energy. So the first is the biological. So for the biological, you need microorganism, bacterias, proper control over those, okay? Then only, and sophisticated equipments and all, then only you can have the energy. Pyrolysis, still you need a proper reactor, okay? You need to have means so that you can cut off the supply of oxygen. So still you need equipments, system to have the pyrolysis, and you need a controlled environment also to do this. Similarly for the gasification, okay? But the combustion, so combustion is just you need to ignite. So just you need a minor spark, okay? Because, and sometimes you don't need a spark also, because you have seen the forest fire, okay? So due to the temperature also, due to this minor spark, you can have a lot of energy. So it can be considered as a direct energy from biomass. The correct answer is the combustion, okay? Now let's go through the different routes. So suppose if you have biomass and then you have some conversion devices, then biological, thermochemical, and the chemical. So the direct one is the combustion, okay? Just uh, do a spark and there will be fire, and you can use the heat, okay? So there is a multiple use of that heat. You can maintain the temperature. So it's also act as a light source, okay? So when like in older time, the heat is also used uh, to remain safe also, because if you are in a forest, so heat is very useful. The other methods like thermochemical or gasification, pyrolysis, so they can use to like for producer gas, bio-oil, chemical and biodiesel, biological can produce biogas, bioethanol. And in all these methods, the end product is same. The end product is the energy, okay? Because this energy stored in the biomass, okay? And we are having different methods to only recover that energy, okay? So you can choose different route, but you are only getting the energy out of the biomass. So the choice of the route, okay, it depend on various factors also. Like nowadays, this biogas is very popular as compared to these, but still they are also popular when you require syngas, okay? When you require the CBG, then this method is popular. When you want to have like biodiesel, then this one is popular. So based on the application, based on the requirement, the availability of resources, we can choose the method, okay? Now please anyone tell me, so we are having the energy, okay? So how this biomass is getting energy?
Due to what we call the decay of the organic material over a period of time.
No, suppose biomass, I think you are not getting the exact point. So biomass can be energy crops, okay? It's not necessary that biomass is after only decaying. So the energy crops, that has not decayed, okay? That is a fresh crop, but still it is a biomass and you are using it for the energy production, okay? The sugar mill waste, the pulp waste, so that is the waste, but that is not organically decayed. So we are having So we have a process to convert the sugarcane into sugar. So there is those are the byproduct. You can consider those as a byproduct, but that is not. So that's why we are calling them waste, but we are using them to produce energy, like agriculture waste and forest waste. So the meaning of the biomass is that
It
it
has
is having,
carbon, actually. It
yeah.
is having
So
carbon.
it's having carbon like organic material. Okay. So now my question is, how this biomass is getting energy? Suppose you are having energy crops. So how the energy is coming into that? Yeah. Yeah. By the photosynthesis. Yeah. Nice. So that's the root actually. So basically we are all dependent on the sun, solar energy. Okay. So I think in our first class we have discussed what is the solar constant.
1367
1367
per meter square.
watt per meter square. So this much of energy, solar radiation, solar energy we are. So it is total, but I think around 1000 watt per meter square is actually coming to the Earth's surface. Okay. So now let's see the biomass composition. So it's mostly composed of cellulose, hemicellulose, and the lignin, and the other like essays, extractives, etc. Okay. So the hardwoods, grasses, crop residue, MSW, and softwood. So these are all come under the biomass composition and biomass, and the composition is cellulose, hemicellulose, and lignin, majorly, and then the other. Okay, so the, the combustion. So combustion is a thermochemical conversion. Okay, combustion involves complete oxidation of biomass fuel into CO2 and H2O with remaining as S. It is one of the oldest process used by human civilization for energy purpose, and predominant fuel, oil seeds, agro residue, tree branches, trunk, dried animal dung, etc. Okay, so mainly we are having CO2 and H2O. So what is meant by the pyrolysis? Option A, complete oxidation of biomass fuel to CO2, water and ash, breaking down the organic compounds under heat in presence of oxygen, breaking down the organic compounds under heat in absence of oxygen. The
It's
option B
B.
is in presence and the C is in absence. The D is breaking down the organic compound under heat in presence of nitrogen.
It is
Option
C.
B.
Option
B.
C.
B.
I think we have two
Option
answers. So one
C.
is option B and option C.
C.
So let's go through the option A. So what is the answer for option A? Suppose option A is a question, then what is the answer? In which we are having the complete oxidation of biomass fuel to CO2, water and ash.
It's a combustion.
Combustion. So it is for the combustion. So it is not for the pyrolysis. So option A is wrong. Let's come to the option B. So those who are with option B, let me know your reasoning.
Because here the heat is given under the presence of heat only the breaking down process of organic compounds will happen, but oxygen in the presence of oxygen, because in the air we are doing that. So air
Okay.
contains oxygen also.
So you mean to say that whenever we are having the pyrolysis, then there should be the presence of oxygen is must.
Yes, yes, yeah.
Okay.
No,
Okay.
no, no. It
Let's
should be absence of oxygen.
okay. Let's see the let's come to the option C. So those who are with option C, what is your reasoning?
Pyrolysis is the process of basically polymerization, I can say, but oxygen is not required in that process. The oxygen should
Okay.
not be present.
Suppose if there is oxygen, then what will happen?
So
There will be combustion basically.
combustion will happen.
Yeah. So if there is oxygen, then there will be combustion. And suppose oxygen is not uh,
Sufficient. Yeah.
sufficient to do the complete combustion, then what will happen?
Incomplete combustion.
Incomplete combustion, okay. So
CO
anything.
CO
Carbon
will form.
monoxide, CO, carbon monoxide would form.
So there is a name for that process. Suppose if you are having the incomplete combustion, if you are having like not the having a proper amount of oxygen to have the stoichiometric balance, then what will happen? So there is a range for the gasification. Okay. So if you are having a little amount of
The
oxygen,
equivalence
then
ratio, your
yeah, so equivalence ratio is there. So if that is 1, then
if it is 1, then complete combustion will happen.
combustion. Yeah. So
Yeah,
if less than 1, then what will happen?
incomplete combustion.
Incomplete combustion. And what is the limit for to have the gasification? So to have the gasification, your ratio will be less than 0.4. Okay, and in between 0.2. So that can be a good condition for the gasification. If it is less than 0.2, then it will be, you can say, the partial gasification and mainly the pyrolysis. Okay, so we will go through this. It's very important. So the answer for this is the answer is C. Breaking down the organic compounds under heat in absence of the oxygen. So the meaning of pyrolysis. So for the pyrolysis, we need to cut off the oxygen, and we are only supplying the heat. So by the heat, we will convert higher hydrocarbon into lower hydrocarbons, and we will generate some kind of also the combustible gases will be there, biochar can be there. Okay, let's see. So you can see you are having the biomass, you are applying heat. Okay, so you're applying so much heat, then what will happen? There will be some vapors. So the vapor will also contain hydrocarbons, different kinds of hydrocarbon. Some hydrocarbons can be used as a combustible gases. So that can be, you can say, the carbon monoxide. Okay, hydrogen will also there, hydrogen will be also there. Then regarding the like condensation, so you are having vapor, so it means the temperature is very high. When you come to the room temperature, then some of the hydrocarbons will be in the condensed form, so that can be considered as the bio oil. Okay, so you can have bio oil. And after the vapor, so this is the vapor, so also there will be at the end there will be some solid also will be there, so that can be considered as the biochar. So this is the biochar. So this is the pyrolysis, and you can have these three products. Okay, so the use of the combustible gas, okay, we can have hydrogen, we can have syngas. The bio oil, we can use it like ethanol we can generate, or it depend, we can use different kind of bio oils. What about the biochar? So do you know any application of biochar? Nowadays biochar is very popular actually. Anybody want to explain about biochar?
For
Using
road
for
making
agriculture.
purpose as a tar.
Okay, so one is, we have one answer is road making, you can use biochar. Okay,
Some of the
so
biochars are
basically
used for
Yeah,
animal
biochar
purpose also.
is used as an agriculture field as a fertilizer. Okay,
okay,
to improve the soil health.
okay, agriculture we can use. Okay,
And biochar can also reduce the what you call the greenhouse emission also.
how?
By using this as a fertilizer and
Yeah,
instead of
using this as
using
a fertilizer. Yeah, okay.
Is it possible to use it for methane decomposition reaction uh, uh,
Yeah, so
as a
we have
carbon as a
discussed.
catalyst?
Yeah, I
Carbon as a
think we have
catalyst.
discussed it already, so we can use it. Yeah, we can use
Uh,
it, but maybe you
Biochar
need
is
to do some kind of pre-treatment.
Yeah, yeah, true.
Biochar is
anybody?
used for medical purpose also.
Medical
After,
purpose.
yeah, after pre-treatment, it is used for medical purpose also.
Okay.
Some of the shampoos, some of the medicines which are given for livestock, they use
Mm-hmm.
biochar.
Okay. But you are forgetting a very important application of biochar. You have covered so many areas, but biochar is popular in not widely popular in these areas. It's a very application actually. It's a very good application.
In toothbrush and toothpaste also, this
Yeah, that's also
charcoal.
a application.
Yeah.
So I think all of you are aware of the RO. I think
Yeah,
all of
Yes,
you are
for
having the
Yeah,
filtration,
yeah.
yeah,
Filtration, yes.
yeah. So that's a
filtration.
very important application for the
the most
cleaning, filtration.
yeah,
It's
correct.
very important. Yeah, yeah.
The most inefficient
Oh,
process.
color removal, charcoal biochar is
Yeah,
used
so
for color.
normally like we are having a carbon filter, inline carbon filter in maybe in your if you
Yeah,
are having different kind of ROs. So we all have a inline carbon filter, sediment filter. Okay. So the carbon filter, so it is widely used for cleaning, not only the water, but different kind of impurities also. Okay. Because you can see it's carbon. So it can react with different multiple gases. Okay. So at different temperatures. So it is widely used for cleaning, gas cleaning also, water cleaning in wastewater pre-treatment, in wastewater treatment. So it is widely used. Okay. So like you have like heard about the activated carbon. So nowadays there is activated biochar also. So basically in the activation we are increasing surface area. So they have more surface area. So in the biochar also we are so the use the activated biochar. So basically the biochar is going to replace the carbon. That's because it's a carbon actually, na. So the
Even in
widely
pressure swing absorption also, sir. Even in PSA technology also, we use the activated carbon. Na?
yeah. So in
So,
PSA we use activated carbon, yeah. So maybe the activated biochar you can use, but the
yeah.
properties of biochar because if you are using activated carbon, so that's okay. But now the question come because you are saying the biochar, but the properties of this biochar depend on what? Depend on the biomass. What kind of biomass you are having? So if you are using activated carbon, it means that that particular carbon is having like similar kind of properties that only depend on the method, how you have prepared that carbon. So mostly that will have a good surface area. But in the biochar, the method is itself is a controlling parameter, but the biomass itself is also a controlling parameter. So different kind of feedstock can have a different kind of biochar. So that's also a good study. So those who want to learn more about it, they can take help of some research papers. Okay. So it's a very interesting one actually. So
So,
nowadays for the biogas also, because when we are talking about the biogas upgradation, okay, and we are also talking about biogas fuel cells because I am working on biogas fuel cell. Okay, so we need to remove the sulfur from the biogas, and the sulfur content in biogas is very high. It depends on the feedstock. So, but the fuel cell, the material that we are using on anode, it cannot have sulfur. If the sulfur is there, then that will deactivate the catalyst. So we need to have 0 ppm of sulfur in the biogas. Then only we can use directly in the fuel cell. So if suppose if we are using the activated carbon, then the cost will be very high. And if we use biochar, then the cost can come down. So the cleaning cost is having a very huge factor in any plant operation. So those who are from the industries, so maybe they can understand it better. So normally you can say the cleaning cost in these cases can be 25 to 30% of the overall cost. So if you're using the biochar, so it's environment friendly material, and that's why it's best way to use. Yes, I think one of you want to ask anything. Yeah, please.
yeah, just want to know about the term activated. What is
exactly called the activated carbon?
So
How it's differ from
activated means
biochar?
activated so suppose you are having carbon, so that is having particular like surface area size, log size, this size. Okay. So activation mean we go at a particular high temperature, we are using some kind of inert gases, so there is some methods. So basically the thing is that we want to increase the area and the pores. So the pores and the area we want to increase, surface area we want to increase in the activation.
Okay.
Sir, I have
Yeah.
one more question. Like
Yeah.
for this question, we said a pyrolysis, we say breaking down of organic compounds under heat in absence of oxygen. So
Yeah.
if I understand correctly, not complete absence, maybe if oxygen is there, but if it is under substoichiometric conditions, then also we can call it as pyrolysis, or
So
zero oxygen is required.
no, for this, like suppose the question is what is meant by the pyrolysis. So theoretically there should be no oxygen. So theoretically there should be absence of oxygen. But still suppose there is a range. So you are at 0.1 equivalence ratio. Then there can be both pyrolysis and kind of gasification. But there is not pure pyrolysis. To have only the pyrolysis, you need to have the absence of oxygen. If you are having little amount of oxygen, then there will be pyrolysis can be there, but still there will be some kind of gasification.
Okay, okay, right.
Yeah. So the organic chemistry. So you can see we are having a hydrocarbon. High hydrocarbon, you are applying heat. Then you can say these are the products. Okay. So we can have liquid bio oil. We have combustible gases, hydrogen, methane, CO, CO2. So okay, inert gas. Sorry, the greenhouse gas, and we can have a biochar. So these are the products of the pyrolysis. So there is a pyrolytic reaction using cellulose. So this is cellulose. You're applying heat. So it is so see the structure. So this was the initial structure. Due to high heat in absence of oxygen, it decomposes into these structures. So you can see the products. Now there are different pathways. The fast pyrolysis, slow pyrolysis, and the gas production. So if you're doing the fast pyrolysis, then the more temperature, short residence time. So you can have 75% liquid, 12% char, and 13% gas. Slow pyrolysis, low temperature, very long residence time. Then 30% liquid, 35% char, and 35% gas. And the gas production. So high temperature, long residence time. 5% liquid, 10% char, and 25% gases. So see, the amount is changing. Liquid, if you want to produce bio oils, then you have to go for fast pyrolysis. If you want to have syngas or hydrogen, then you need to go for this gas production mode. You need to have high temperature and long residence time. Okay. So it depends on the product that you require. Okay. So if you require more liquid, more char and more gas, so you can select the method as per that. So the question is the condensate obtained during pyrolysis is termed as bio oil, liquid organic hydrogen carrier, biochar, activated carbon. I
It's
think
a
we have
bio
covered it
oil.
already. Yeah.
Biochar.
Biochar. Okay. Nice.
No, bio
Bio
oil.
oil.
I think, yeah, you missed the question, I think. Please go through the question again. So don't be in hurry because in your exam also, just for exam, so sometime the question can be tricky. So first go through the question very carefully. The question is the condensate obtained. So see the term condensate. I think
It's
now
bio
now you
oil.
will change your answer. Yeah.
Yeah, bio oil.
Yeah. Nice. So options are bio oil, liquid organic hydrogen carrier, biochar, and activated carbon. So I think all are agree with the bio oil. So you know that when we do the pyrolysis, so we are generating the vapor, okay? And the vapor is having multiple hydrocarbons at high temperature. But when we reduce the temperature, so at room temperature, some hydrocarbon will have condensation and they will convert into liquid form, okay? And you can, as they are hydrocarbon, so they will have some calorific value. So you can use them as a fuel oil. So because they are generated from a biomass, so that's why we are calling them bio oil. Okay, the correct answer is A. Now, what is the calorific value of lignite coal? 17 to 22 megajoule per kg, 27 to 30 megajoule per kg, 35 to 40, and 5 to 10 megajoule per kg.
Seventeen to 22 megajoule per kg.
Okay, we have one answer. 17 to. Sorry, I missed your answer. Please repeat.
It's a 70 to 22 megajoule per kg.
Okay, 17 to 22 megajoule per kg. Okay. Anybody else?
5 to 10 megajoules per kg.
Hi.
So
I
we have
guess it is
two
less than
answers.
70, so it should be 5 to 10 megajoules per kg.
Okay, so it's a direct like database question. So maybe it's like not a like that directly connected to concepts. Okay, so there is no issue in right or wrong. So the answer is B, 27 to 30 megajoule per kg. So it is the value of calorific value of lignite coal. So now how the coal is formed? So the biomass to coal. So you can see biomass is there. So that will decompose, go into the earth bed. Okay, then with time and with the pressure and also with temperature, it will convert into lignite, and then after some time it convert into coal. Okay, so the coal reserve that we are having right now, so it is the result of millions of years. Okay, so that's why we are, yeah, it's a very good question actually. So what is the meaning of renewable fuel and non-renewable fuel? So coal, what is the coal? Coal is a renewable or non-renewable fuel?
It is a non-renewable.
Non-renewable.
Non-renewable. Okay. And then what is the renewable fuel?
Like
Solar,
solar,
hydro.
wind, all these things are
So
renewable.
how will you decide? Okay, this fuel is renewable or this fuel is non-renewable.
See, for non-renewable means once we use, we cannot regain it back. It
Okay,
is
we
gone.
cannot regain it back. Okay. So, but
So
if you see the coal from this diagram, I can see how the coal is formed. So I can see very clearly that coal is formed only from the biomass itself. Then how it become the non-renewable? Because you can see the biomass is only forming the coal. And when we are using the biomass to have energy, we are calling it biogas, bio oil. It's renewable. It's coming under renewable. But why we are not saying the coal as a renewable fuel? But still the coal is generating only from the biomass.
Because it takes millions of years to form.
Okay. So then what should be the definition of renewable and non-renewable?
See,
How will we differentiate it?
renewable resources, no, they will be consumed faster, but no, to bring it back to that no position, it will take some time. So that is the way, replace very fast, but to make it again to to the stock level or whatever the available resource to make it, it will take some time. But our consumption will be very fast. Means we will be replenishing it very fast, but the formation will take some time. This is
Right.
the non-renewable actually. So if the renewable normally defines to the replenishment speed or no, the formation speed will be more or less the same.
Yeah, nice, good answer. So
Moreover, renewable and non-renewable, renewable will have an effect on the environment, but non-renewable sources they don't have any impact on environment.
no, I don't think so. I don't agree with rightly on this. So you are saying the impact on the environment. Okay, so like just forget right now, actually now period. Actually, suppose if we are only using the coal maybe 1,000 years back, then you know the CO2 is also required for our environment. So that time I don't think so coal can be the non-renewable fuel, because if we don't have the right amount of CO2, then the earth cannot have the right amount of temperature, because we still need heat trapping is required to maintain the temperature. Otherwise we can go into the cold era. Okay, so directly you cannot say the pollution. What is the pollution? Like it only depend, like the timeline is very important whenever we are considering these things now. So the timeline is very important. Okay, so maybe 1,000 years back coal was not a non-renewable fuel. It was a, you can consider it renewable fuel and also a green fuel also, because if you are using only, suppose only few hundred people are using coal, okay, they are contributing, they are there is emission, but is that emission is enough to hamper the our environment? No. So we cannot say okay coal like hundred of years back was a polluting fuel. Okay, but now the consumption is very huge, the emissions are very huge, and we are impacting the environment due to this. That's why it's come under this category. And also the timeline, so we cannot replace it in our lifetime, in our children's lifetime. Okay, in our next generations we cannot replace it. It requires millions of years, then only the new coal will be formed. That's why it is non-renewable fuel. The renewable fuel that you can replace after some duration, or but still suppose you are saying okay, uh, uh, suppose you are generating the biogas. Okay, so also it depends that, suppose you are having the energy crops and you are generating energy. Okay, so can you consider then them as a renewable? It also a point of
No,
debate actually.
no,
Yeah,
actually, which methods are used for generating or creating them? That is also important.
yeah,
Like
that
if
is
you use
also,
clean methods, then it's clean.
yeah, yeah. Okay, so the timeline is very important in these things. Okay, the timeline is very important. And the things that the organic material that considered as a waste. So suppose if you are not applying a particular method to use that waste, then it was a waste. Okay, so that was only creating pollution and so much of energy was destroyed. But we are having a particular method and we are extracting more energy out of that. That's why we are considering there is a clean way. Okay, because otherwise it was doing the pollution, but now we have extracted more energy out of it. So we are having a way, and we are also so if we are extracting the energy, so the degradation rate is also faster. Okay, so otherwise anything is to degrade. So when anything will degrade, when it will lose all energy. So suppose if a particular content is having 100 amounts of energy, so for 100, like one amount can degrade per year, so it will require 100 years. But suppose you are having a method and you can extract from that waste around 80 uh, units of energy, so only 20 units is remained. So suppose that particular material was supposed to degrade in 100 years, but you employed a method, and now the output of after your method is having only 20 units of energy, so that will degrade in 20 years only. So basically you have reduced 80 years in the degradation. So after so you have reduced a huge amount. That's why we are consider it renewable and the green waste. So I think uh, you should like spend some time to learn, like spend some more time to think about the green fuel is a good way or not. Like nowadays we are saying okay, electric vehicles. So what do you think? Are they green? So
No, it
basic,
depends, sir. Actually, it
yeah.
depends
So
again.
No,
it depends
no,
because we are. So what actually they are doing? So we are replacing the the petrol or diesel vehicles with the electric vehicle. So what we are doing? So we are only shifting the point of emission. So now if we are only using the petrol diesel vehicle, so our point of emission is what? Our city, where most population is there. So we are polluting our city. But what about, and now suppose we are using electric vehicle, so still we need energy, we need electricity, and from you are charging from your home. Okay, at your home you are having the electricity from a state board. And how they are getting? They are getting from a power plant. And how the power plant is generating electricity? From the coal. Okay, so that's the point. So earlier your pollution point was your city, but now the pollution happening at the power plant site. So you just shifted the pollution point, but not the actual pollution. If you consider the whole earth environment as a control volume, then that is having the same amount of pollution. Okay, so you are just only shifting until unless you are using the renewable energy, like either you are using the PV or any kind of renewable energy, and you are charging your vehicle from that energy, then only you can consider okay, I am doing something greener. And also if we go more deeper into it, then what about the waste? Because you are using batteries in that, so that batteries will also create so much of waste. So in near future it will be going to a huge problem to maintain the waste of the batteries waste. Actually it's going to be a huge issue. Okay, because it's very difficult to maintain that. So okay, it's we will discuss in any other class regarding this, but it's a good point to study. So spend some more time in this thing to learn more about it. Yeah. So now the hydrogen using coal gasification. So you can see here we are having a biomass. So the biomass is having 55 to 65 gram of hydrogen per kg biomass. Okay, 50% of oxygen and 40% carbon by weight. Caloric value is 14 to 17 megajoule per kg for dry biomass. So it can convert into peat in 10 to 15,000 years. So see the timeline. So when you're converting into the peat only, it required 10 to 15,000 years. Then it will have 17 to 20 megajoule per kg of caloric value. And organic matter 60%. Lignite 6 crore years. And 60% carbon, 35% moisture, and the CV will increase. Then 10 to 30 crore years, bitumens. CV again further increased. Now no organic molecules, so only the carbon. 35 crore years, 80 to 95% carbon, negligible moisture, and 35 to 40 megajoule per kg. And the hydrogen will be 20 gram of hydrogen per kg of coal. Okay, so this is the cycle. So the biomass can convert into peat, then lignite, then bitumens, then anthracite. So the anthracite is a top quality coal, then the lower quality bitumens, then the lignite, then the peat. Anyone is from steel industry? Like anyone is in from any industry using, are you using any kind of coal in your industry?
In power plants, we are using coal. We have
Okay,
power
so
plants, so
which coal you are using?
uh, we uh, we are importing coal from Indonesia.
Okay, so,
So
so do you know the category of your imported coal?
yeah, it is lignite,
Lignite.
bituminous and lignite. Yeah, it's a
Okay, so you are
combination of bituminous and
bitumens and
lignite.
lignite. Okay. Okay.
And calorific value, we normally in industry we just unit we call is a 4,000 kilocalorie per kg instead of megajoule. We talk in kilocalorie.
Okay.
So it is
Okay.
in between 4,000 to 5,000 kilocalorie per kg.
Okay. Okay. So the next question is, in the air gasification process of biomass, the typical yield of hydrogen is gram per kg.
It is 50 to 60 gram per kg.
Okay, we have one answer 50 to 60. Anybody else? So the question, go through the question, air gasification. Okay, so gasification is there of biomass, not only biomass, air gasification of biomass.
80 to 90.
80 to 90. Okay. Okay. So the correct answer is D. So we only have 35 to 40 kg, 40 gram of hydrogen per kg of biomass in air gasification process. Now let's see about the biomass gasification process. Okay. So basically it's divided in 4 stages: the drying, then the pyrolysis, then the combustion, and then the reduction. Okay. So the pyrolysis is also happening, the combustion is also happening, and reduction is also there. So this combustion is providing heat for the pyrolysis, for the drying, okay, and for the reduction. So you can see in the drying we are removing the moisture, pyrolysis forming charcoal and tar. It's volatile. Then there will be supplying oxygen or air. Then this tar, so this tarry gas, okay, the volatile gas, it will have some reaction with the oxygen and it will burn and release energy, okay, very fast. And the charcoal, it will solid, it is slow. So then it will further convert into the hot charcoal. This charcoal will convert into hot charcoal and generate the hydrogen and CO. So finally the reduction. Okay, so this is the process of gasification. The reactions, so the combustion biomass undergoes pyrolysis and subsequently combustion. The above product gets react with the char produced in the pyrolysis process in the reduction zone and generate producer gas. So the reactions, I think we have already covered these reaction: water gas, water reaction, water shift reaction, methane production, and combustion. So this is the, you can say, if you are having a gasifier, this is your gasifier. So you will have, you are supplying the biomass here, okay. Then you have this zone, drying zone, pyrolysis zone, then the combustion zone, reduction zone, okay, and the S removal zone. So supplying the air from this point, gas is coming out from this point, okay. So this zone is supplying heat in radiation, in the radiative manner to the upper side, and in the convective transfer through the bottom, through this side, okay. And the output is coming through this side. So the output is we are collecting at the, you can see the bottom side, and is considered downdraft gasifier. That 4 types of gasifier: updraft, fluidized bed, and in-train flow gasifier. So drying temperature is 120 150, pyrolysis 280 to 500, oxidation 1100, reduction 800 to 950. So the heat required for all these process is going through the combustion, oxidation. Okay. So the biomass gasification can be like either air gasification, oxy steam gasification. So if we are considering the air gasification, then the maximum hydrogen can achievable is the 60 gram per kg of biomass. It is achievable, okay, but the yield is 35 to 40 gram per kg of biomass, okay. So if we are using the air, then what will happen? If you are using the air, then it will have oxygen and nitrogen. So oxygen will take part in the combustion, but what will with nitrogen will do? So it is inert gas, so it will be come with the your output. So if you consider the output, so there can be 45% by volume fraction in the producer gas. So the overall composition of hydrogen will come down to 20%. Now what will happen? So you are only having 20% of hydrogen. And now suppose you want to have pure hydrogen, then you need to apply a process PSA, okay, or any other upgradation method. So the concentration of hydrogen is lower. So it will increase the separation cost because you need to separate 80% of gases and you will only have 20% as output. And still you will not have 20% whole 20%. Maybe you only get the separation efficiency is maybe 80% or 70%. So you will get some part of this 20% only. So basically it will increase the separation cost. So it's not economical to separate. So then what we can do? We should use oxy-steam gasification. So instead of air, we can use oxygen to increase the hydrogen volume fraction by eliminating the nitrogen. And we can also use steam as a gasification agent. We can enhance H2. So because H2O steam, what is the formula H2O? So we are having hydrogen also in the steam. Okay. So this hydrogen can also come out from the steam. So we can enhance the hydrogen yield using carbon and carbon monoxide through water gas shift reaction and water gas reaction and water shift reaction. Okay. So it's require heat input because it's endothermic reaction. But high temperature is issue. So high, because it require high temperature, so the operational issue will be there. So
Sir,
the
in the
question was
oxy,
so the question was air gasification. Okay. So in the air gasification, the answer is D, 35 to 40. Yeah.
sir, if we use oxy gasification, only oxygen, then also the separation is required, right? Because from air we need to separate the oxygen. Like air gasification, even if we
Yeah.
use only
So
oxygen for gasification.
so that is a different thing now. You need to only separate. So whenever you are separating the nitrogen, then that is a different unit. So your input is air only. Okay.
Yeah,
So the
yeah,
nitrogen is and air. Only two things are there. 20.9 is O2 and the rest is nitrogen. So you can easily separate because you are separating nitrogen. So the thing that you want to separate it is a very high quantity, na.
yeah.
So you can separate it, na. But if you consider if you don't, so that is a separate unit. But after that, only the oxygen is going into the gasifier. Okay.
Correct.
But suppose if you are not separating out the nitrogen first, then this nitrogen coming in this proportion and it will decreasing the overall composition, decreasing the overall composition of the hydrogen and CO. Then it will increase the cost.
Yeah, you mean to say the other impurities also we need to separate it out in air gasification, right? Like CO, CO2.
So no, because suppose the thing is that suppose there is CO 20% CO, so, and I want more hydrogen. Then what I need to do? I need to apply a water gas
I
shift
have to
reactor.
remove.
No,
Yes,
I,
yes,
I need to
correct.
apply a water gas shift reactor. Okay.
Yeah,
So suppose this is my gas composition, and my gas composition is having 45% by volume of nitrogen, and I am having a water gas shift reactor. So and suppose this is my inlet, this is my outlet, and suppose I am having 100 mole per minute of flow, and this 100 mole, the CO is only 20 moles. Okay.
yes, yeah.
So the size of this reactor, tell me two things. How we determine the size of a reactor? Any reactor, water gas shift reactor, any like reforming reactor, we consider in our first class. How we determine the size? Suppose I want to have like more than 90% of CO conversion in my
Yes.
reactor. Okay. Then I need to use a catalyst. Then what are the thing I need to select for 90% conversion? The one thing is the temperature. Okay. I need to maintain the
Yeah.
temperature. Okay, you can maintain temperature. What is the second important thing? to have the conversion, good conversion.
Reaction time.
Oxidant that we are using.
Yeah,
Oxidant.
the reaction time, yeah, very good. Residence time. So
Yeah,
this is
residence
very
time.
important thing, residence time. Okay. Now come on this point, residence time. So you require a particular residence time. Okay. So
Yeah.
now if your inlet fuel is diluted, so basically you are having so much nitrogen and you need to maintain residence time. Okay, then what will happen? To have a
We need to have more residence time because
you, yeah. So maybe you need to change, because if you are only using this much, okay, and your flow rate is this, okay. So to have a, like suppose you require uh, around like 40 mole per minute of pure, like you need to convert like hydrogen, okay. So you need to convert the whole 20%. So you need to increase the size
yes,
because your gas is diluted. So you need more residence, you need more time, you need to increase the size, you need more catalyst
yeah,
because your gas is diluted. So the size will increase, the cost will increase, the time will increase, na.
yes,
Overall
yes,
time will increase. So the thing is that if we separate it in initial stages, then what will happen? Our CO will be around 40 to 50%. Then it is more easy to
yeah,
you can
separate.
reduce you can reduce the size of your reactor.
True, true, correct.
Yeah,
Got it.
you can reduce the residence time. So those are the thing. So basically you can consider dilution. So if you are having
Yes,
more diluted fuel, basically you will increase the cost. So
yes,
that's
sir,
why
got it.
we want to remove the nitrogen first in air separation unit. So in this, because our target is separating the nitrogen, so that is more than 70%. Okay. So for in the PSA also, if you are using the PSA for hydrogen separation, so basically the hydrogen content should be more than 50%. Then the PSA is economical. If your hydrogen concentration is less than 50%, then it's not that much economical. And maybe
Yeah, yeah, true.
some PSAs are also requiring more than 60% of hydrogen concentration. Okay.
Yes, thank you.
Yeah. So the role of steam in hydrogen production. So what is the role of steam? So in the steam reforming, so we can have CO plus H2, water gas shift reaction also we can have CO plus H2, and water gas reaction, carbon plus H2, CO plus H2, water gas shift reaction, CO2 plus H2. So typically a biomass containing only 50 to 70 gram of hydrogen per kg and yields 35 to 40 gram only through air gasification. Okay. So biomass contain only how much? 50 to 70. And we can only get 35 to 40 gram. But if you use oxy steam gasification, then the yield can be 104, almost double for hydrogen, gram of hydrogen per kg of biomass using excess steam as a reactant. So basically the this H2O is also taking coming out. So you can see the total yield is increasing more than 200%. Okay. So you can see you are changing the steam to uh, steam ratio. So it's changing. The hydrogen yield is increasing. Okay. So the next is, yeah. So these are the ratios H2O to biomass mass basis, like you are increasing 0.4 to 2. So see the concentration of hydrogen 41.8 to 50.5, CO 27.2 13, hydrogen yield 104. So what has happened here? Anybody want to tell me? If we are increasing the amount of steam, then what is happening with this data? Because you know because we know one thing, we cannot, we only convert the energy, we cannot destroy, we cannot generate, we can only convert. So what is happening here? How this extra
Hydrogen,
hydrogen is coming?
hydrogen yield is increasing. It is
Yeah.
because of the steam usage. Like
Okay,
more
steam is.
steam if you could, yeah.
But how it is increasing?
Because from the reaction with the steam, the what you call the hydrogen is also releasing, right? So that hydrogen also will includes to the yield.
Okay,
It
so that,
contributes to the overall
yeah,
yield of the hydrogen.
but how that is happening now? So from this data, can you see anything which you can relate from this data? So I'm giving you hint. Observe these two rows carefully. H2 yield and CO yield. What is happening? And also this first row. When you're increasing the amount of steam, then there is change in the
CO, yeah.
hydrogen fraction and CO fraction. What is happening?
CO is decreasing, hence hydrogen is increasing.
Yes. So CO is decreasing. And why CO is decreasing? Because when we have hydrogen, then CO can react water gas. Shift reaction can be there.
Shift reaction, yes.
Yeah. So water gas shift reaction can be there. And what they will generate? The CO2. So if you
CO2
consider
and
this, yeah, so hydrogen we are considering here, so the other will be the CO2. Okay, so basically we are decreasing the yield of CO. Otherwise, you need to have further water gas shift reaction. Then you are again adding the steam. So either you can directly add the steam in the first process itself, you can increase the ratio. So internally only in the same gasification reactor only, you can have some amount of water gas shift reaction that can decrease the CO amount. So now you only have 13% of CO. Okay, so that's the thing. And also it will decrease the carbon deposition. Because if there is low steam, then there can be CO. This association can be there. Okay, that can deposit the carbon. Okay. Asim, you are unmuted, so please mute yourself. Now, next question. Which among the following act as a reducing agent in order to obtain syngas from biogas gasification? Charcoal, oxygen, aromatic hydrocarbon, and hydrogen.
option A, charcoal.
Okay. Anybody else? Okay, so correct answer is A, because charcoal is the reducing agent. Okay. C plus CO2, carbon plus CO2, it's just 2CO is known as which reaction?
Bodard reaction, C.
Yeah, Bodard reaction. We have already covered this earlier. We know the steam methane reforming reaction, water gas shift reaction we have covered. Now this is the Bodard reaction. Is it endothermic or exothermic?
It is exo.
It's exothermic or endothermic? Because you see the sign. It's reversible reaction. So either it can be 2CO to carbon plus CO2, or it can be carbon plus CO2 to 2CO. Which one is exothermic and which one is endothermic?
First one is the
First one is
endothermic.
endothermic and the second is
Second one
exothermic.
is exothermic.
Okay, why?
Because in first reaction we have to break the bonds. So we need to give
Need
the
energy.
energy.
Yes.
Yes, right. Okay, the answer is C. What is the color code assigned to hydrogen produced using the methane decomposition process? Green, turquoise, blue, and gray.
Option 2,
Gray.
Okay,
turquoise.
we have two answers.
Turquoise.
So
Turquoise.
those who,
Turquoise.
okay,
Great.
and what is the reason? What is the for green hydrogen? Let me know the color code. What is the meant by the green hydrogen?
All the methods to produce the hydrogen should be clean, environment friendly. So that is green hydrogen.
Okay,
Blue hydrogen is with CCUS,
mm-hmm.
it's carbon capture sequestration.
Okay,
And gray is from lignite.
no, gray is
See,
from the natural gas.
yeah,
Natural gas,
let
yeah,
me, let
gray
me,
is
let
natural
me
gas.
tell, green hydrogen is from renewables, okay? And Turquoise hydrogen is from without carbon capture, utilization, waste. Sorry, NG with natural gas. From natural gas, it will be a Turquoise hydrogen. And blue hydrogen will be from fossil fuels with the CCU. Yes.
Okay, you are a little bit wrong in this thing. Sorry to say, but okay, let's see the answer. So
Alcohol check.
answer is
Night
the,
alcohol check பண்ணிட்டு
yeah, answer is the turquoise
சித்தூர்ல ஒரு
hydrogen.
இன்சிடென்ட் ஆயிருக்கு.
So let's see more detail
4
about
டிரைவர்
it.
குடிச்சு
So now
வந்து
I think it will
உள்ள
be
போட்டு கேட்டேன்
Santosh. I think you are Santosh. You are unmuted. Please mute yourself. Yeah. So now you will get to know about all the color of hydrogen. Okay. So hydrogen is the one of the key replacement for fossil fuel in industry and a critical factor in the race to net zero CO2 emission by 2050. We all know that. Okay. So now if we are going to enough hydrogen, we are going to have enough hydrogen to meet our growth in and demand. And for the low carbon production of the gas will need to be scaled up. So these are the hydrogen that we are currently having. So let's start from the red yellow one. So yellow is the typically refers to hydrogen made from electrolytically with solar energy. If you're using solar energy and you are using the electrolytically methods to generate hydrogen, that comes under solar hydrogen. And the green hydrogen, that's now we are all focusing, made by the electrolysis of water using electricity from the renewable source to split water into hydrogen and oxygen without emitting CO2. There is no CO2 emission. You are using the electricity from a renewable source, then only it is green hydrogen. And also if you are generating hydrogen from like any renewable biomass also, okay, then it can be also considered green hydrogen. The white hydrogen, naturally occurring hydrogen found in underground deposits. Okay. The gold hydrogen, produced by fermenting microbes found in the depleted oil wells. The process relies on CO2 capture for carbon neutrality. So you need to capture the CO2 in this process, and microbes by fermenting microbes found in depleted oil wells. The gold hydrogen. Brown hydrogen, traditional process making hydrogen which use either black or brown coal, lignite. It releases high amount of CO2. So from the coal, it's coal or black also. Black and brown, they are from the coal. Okay. Now the black is from the, you can say, the very poor quality of coal. Brown, little bit good quality of coal. Gray is derived from the natural gas using steam methane reforming or different kind of reforming we have discussed. And the most common production technique, I think more than 50% of world's hydrogen today is from the steam methane reforming, and that is a gray hydrogen. It generates fewer emission than black and brown methods, fewer than these two. So the emission is around, I think, 9 to 10 kg of CO2 per kg of hydrogen. For the black and for the brown, it is around 14 kg of CO2, and for the black, it is around 19 kg of CO2 per kg of hydrogen. Turquoise, so it's a splits methane. So the thermal decomposition that we have discussed, the methane decomposition, so it splits methane from natural gas into hydrogen. The feedstock is natural gas, that's okay, but we are using the decomposition method and we are having the solid carbon black and the hydrogen only. Okay, so we are having a solid carbon, so there is no CO2 emission. So you can collect that carbon and you can sell it, you can use for any other purpose, so that come under the turquoise hydrogen. The blue hydrogen, so in this we have to capture the emitted CO2. So the main path for global decarbonization it combines gray hydrogen. So the method that popular in the market is gray hydrogen, widely established, commercialized. Most of industry are having their plants. So the industry don't want to expand, like want to change the whole plant and method. So what they can do? Okay, they are having steam methane reforming, fine. They can install CCUS, then capture the CO2. I can use it for other purpose. So then it can become the blue hydrogen. The purple, pink, and red, they come under the category like electrolytic production process similar to green but powered by the nuclear energy. So if you're having nuclear energy, then you consider purple, pink, and red. So this is the wheel of hydrogen, wheel of colors of hydrogen. Okay, so you have seen the different colors. So nowadays we are focusing on green hydrogen everywhere. Okay, what is the temperature range in non-catalytic methane decomposition process?
1100 to 1300.
Yes, we already covered this. It's 1100 to 1300. Amount of hydrogen contained in biomass?
55 to 65 gram per kg.
55 to
Yeah,
65.
nice, because you can also directly eliminate from the options. This content is very high. It is also very high. It cannot be. It is very less. It cannot be. So only this option seems feasible to me, and it is the right answer. Which among the following is the thermochemical conversion method of harnessing energy from biomass? Biodiesel, biogas, pyrolysis, hydrolysis.
It is C and pyrolysis.
Pyrolysis.
Yeah, we have covered this already. So it is the pyrolysis. Which constitute of biomass can be utilized for biogas production? Hemicellulose, lignin, cellulose, and methane.
Cellulose.
It's a cellulose.
Yes.
Cellulose.
So it's the cellulose. So now, do you know any difference between the cellulose, hemicellulose, and lignin? What is it? Because I'm not from this biochemical background. I'm from mechanical background. So anybody is here from the biochemical background who can explain a little bit about these? Okay, so I have a reference, so we can just follow a reference for so this is the source. So the major difference you can see in the structure. Okay, cellulose is unbranched, unsubstituted linear polymer, but probably bonds to lignin. Hemicellulose linear polymer, often with side groups, and lignin still a matter of debate if the polymer is linear or web shaped. Okay, bonds to hemicellulose and maybe cellulose. Then the monomers, they are the monomers of these. Then the degree of polarization, so 8000 and up, 200 in most case, and unknown, that is 20. So the reactivity, low and even reactivity, high reactivity, and low reactivity. So I'm not very good. I'm not having very good knowledge about these. So I just have a reference. I copied it. So those who want to learn more about the differences, so you can refer this journal. Okay. So in simple terms, in cellulose, the main substance which makes up the cell walls and fiber of plants is cellulose. Lignin, an organic substance which acts as a binder for the cellulose fibers, adding strength and stiffness to the plant cell wall. So lignin is for structural strength and stiffness. The monomers for cellulose is the D-glucose, and the monomer for lignin is the para commonly alcohol. Okay, so sniply sne what is this name? Snappily alcohol, so very like weird names. So then a straight chain polymer, irregular polymer, polysaccharide and phenolic polymer, the main component of the primary plant cell wall. It occurs as thickness of secondary cell walls of fibers and vessels of vascular tissues. Okay. So it's constitute 90% cotton fiber, 40 to 50% of wood, and 57% of dried hemp. Mainly occurs in the wood and the bark. So the important point, this one. So the cellulose only the gut of the ruminant animals can digest. So the ruminant animals can digest this cellulose. The lignin is totally indigestible. It's important point. It's totally indigestible. The reaction of volatile matters obtained in the pyrolysis process with oxidant results into the formation of
CO2, H2O, heat and light.
yeah. So we know this, we have discussed it. CO2, H2O, heat and light. What amount of oxygen is supplied for the gasification process? I think we have discussed this also regarding the equivalence ratio.
20 to 40%.
Yes, nice. So 20 to 40% is required for the gasification. Otherwise, not required for the process. It means it is pyrolysis.
Pyrolysis.
Yes,
Required above
pyrolysis.
stoichiometry combustion 60 to 80 gasification, but combustion predominantly. Okay. So biomass you can heat, pyrolysis convert to volatiles, then the oxygen converted to H2 and CO2, charcoal you can do the reduction, so you can get the syngas. So it's a part of for the gasification. So yeah, see this range actually. So this range is for the combustion, 0.2 to 0.4 for the pyrolysis, for the gasification, and less than 0 for pyrolysis. If you are in this zone, then you are having both the gasification, little bit gasification, and the majorly pyrolysis. You are in this zone, then majorly the gasification and combustion. So you can, this is very important, this percentage is important for the combustion 0.8 to 1.0. If 1.0 is, then it is stoichiometric ratio. Which among the following can be used to increase the hydrogen yield in the biomass gasification process? Steam, oxygen plus steam, natural gas, and oxygen.
Oxygen plus steam.
Yes. And why? How this can increase the amount of hydrogen?
Because steam, as we have seen, it will reduce the yield of CO and so thus increase the
Yes.
yield of hydrogen.
Yes, this is the nice answer. So basically we are not adding any extra hydrogen. The thing is that the now that the steam we have added already, okay, that is reacting with the CO, okay, and converting that CO plus H2O into hydrogen and CO2.
CO2. Yeah.
Yeah. Which among the following can digest lignin? Important, yes, because we have seen that lignin is indigestible. So which among the following can digest lignin?
Microbes.
Okay. Anybody else?
Microbes.
Okay, so enzyme, microbe, and viruses, they are not able to digest lignin. Only fungus can digest the lignin. Important question, okay? So fungus can digest the lignin. What is the calorific value of vitamins coal?
55 to 40. Sorry, 28 to 37.
Yes, nice. So the correct answer is 28 to 37. So now we are talking about coal. So then the coal gasifier. So in the class, professor discussed about the coal gasification also. So you can see this is the reactor, okay, and it is underground reactor, okay. So you need to supply the coal, need to supply the oxygen. So this is the air separation unit. You are having air, it is separating out, the nitrogen is separating, going out, the oxygen is going in, the coal is going in. You are having reactions and you are having the gas output. So suppose if you want to produce the hydrogen from the coal gasification, then what you have to do? You have to first crush the coal, then gasifier, okay? Then we need to remove the particulate removal. Then it is very important, sulfur removal. Why it is important, sulfur removal?
Because sulfur acts as a poisonous this thing to the what we call this downstream process.
Yes, because we need to produce the hydrogen. Okay, pure hydrogen. Then we all know that we need to convert the CO into
CO2.
hydrogen using
CO2.
water gas reactor. Or water gas reactor require a catalyst, and that catalyst will deactivate it with the sulfur. Okay, so we need to remove the sulfur. Then moisture removal, CO2 removal, then water gas reactor, then H2 removal. Now we have pure H2, so we can transport it. We can use in electric power plant. We can use in fuel cell to generate electricity. So this is the diagram. We also having the underground coal gasification. So I think Russia has already, professor discussed about this. So Russia has already having a mature technology about this underground coal gasification. So we all have like coal mines, underground mines. So we can use those mines as a reactor, and we can directly supply the like injection wall. We can supply the coal, okay, and from this we can get the gases, and this part is used as the reactor. So this is about the underground coal gasification. Okay, so thank you. I think it's we have discussed so many questions today. I hope it helps. Okay, so any doubt? We still have 5 minutes left. So any doubt? So if you have any query, any doubt, you can discuss now. We have 5 minutes left. Okay, so one of you I think was saying that you have some queries, so you can email me. So you can email me your queries. So if you are having a query regarding your question, any discussion, so I am open to any kind of discussion also, no issue. So you can email me and we can have a discussion.
Okay, sure.
Yeah. So are we going okay? And any feedback regarding the class?
Yeah, it's really useful. You shared a lot of things. Thank you.
Okay, thank you. So do you want like, I think I have covered around 20 question in every class. So is it enough, or do you want more question or more discussion, less question?
Sir, if you add some few problem solving, that will be very helpful.
Okay, the problem solving, the tutorials that I think we are having on the course. Are you talking about those?
Yeah, so they're also almost 60% on the course topic, and 30 to 30% covering the problem solving,
Okay, okay.
like that.
Okay, so
Following.
maybe in next class I will try to have one or two question about the numericals that professor discussed in the class. So maybe we can have a discussion about those also. So those who are having any queries regarding that, so that will be cleared in the class. Yeah, good
Sir,
suggestion.
Yeah, sure.
Thank you.
in the final exam, numerical part, how many question we can, I mean, what percentage we can expect, sir? Any idea?
No, I don't have any idea about this. Maybe they have given some kind of scheme, so maybe you have referred that scheme. But I don't have any idea.
Okay. Thank you.
Okay, anything else?
No, nothing. Thank you.
Okay then.
Thank
Thank you everyone. So you can have this PPT and the meeting recording, and NPTEL team will share this to you. And next time I will try to include some numerical also. Okay. Okay. Thank you. Bye bye.
Thank you. Good night.
Yes,
Thank
Good
you.
night.
thank you.
Bye bye.
Night.
Thank you.
Bye.